you can say they're sometimes like this big, and then they're long like this, 1 point here and 1 point here, 1 point here. Now, nothing much needs to change here for this pointing into a totally different direction. So people sometimes get misled, this is not so good data, or we don't know that. This is just a ripple, and the tiniest ripple can create dramatic effects. So that's why I mentioned before, creating production hill shades, you should do from the, and you see that everywhere. Here's another of these lines. You can see the scan line overlap. So you should first create a raster and then do that. And we're going to do this in the next step, but we'll do it a little different. Because we're using a new software at the same time, so we learn two things at once. Do you still have that open, LAStools? If you still have it open, never mind. Let's just close it. I don't want to confuse people by mixing too many concepts at the same time. Okay. So we're now going to create another hill shade a little differently. But we also will this time not run tile-based processing. This was tile-based processing. We run 8 tiles in parallel and create 8 separate tiles. In LAStools, there's a tool, or there's something I call the blast extension. And if you look, it's called LAStools. Not LAStools, it's called LAStools. Now LAStools, the difference to LAStools is not obvious at first, because it also rasters points with a tin, but it can handle up to 2 billion points. And LAStools can only handle up to 20 million in the current 32-bit version. There'll eventually be a 64-bit version that can handle more. So billions of points. That's good because, we are collecting a lot of points. That means I can now merge all the points into one and not work with tiles. Before we created, we had like 10 tiles, all separate DTMs. And in order to make those align nicely, we had to use buffers and render a bigger tin and then only make a cookie cutter. This time we're just going to use all the points and create one big triangulation. So, and that's important. And when we now choose our points, we must keep in mind there's no cookie cutting happening here. We're going to merge all the points now on the fly into one big file. And that means we should not use any of the tiles that have the buffer, because then we will merge points from multiple files into the one file. We now want to use the ones that have no more buffer, because we don't need the buffer this time, because we're going to use all the points. There will not be any cuts. The only cut is sort of at the extent of the points, but there you always have that. This you can never avoid. So I'm using the tiles final, and now I put all points into one file, sort of on the fly, and there will not be any cuts in the triangulation where I can have bad things happen. If there's points missing here, it doesn't matter because I'm going to use this tile also and put them all together. And in order to put them all together, I must merge the files into one. I want to use an output format, the build format this time, because the build format can be read natively by LAStools as input. And I'm not stop using tile bounding box because I use all the points. There will not be a tile bounding box anymore. When I merge them, the tile bounding boxes get removed because tile bounding box only works if you work on individual tiles. And I want to give it an output name. Well, let's first select the directory. The directory should be, since it's going to be merged, let's put it right in this directory. And the name we're going to give it, well, I think a good name would be Agno DSM. Then we can choose the right one here too. So Agno, it doesn't say no DSM, it says Agno DSM. Yes DSM. So you see also now we can run only on one core. But actually the last extension is always running on 3 cores because it uses a special streaming tin technology. And if you remember how I started my talk, that's how I got into LiDAR. You know, I was at Berkeley, you know, I solved this problem, how to triangulate 1 billion of points using a small memory buffer. That was exactly that technology. And that's actually unique to LAStools. There's no other LiDAR software that has this technology, at least not that I'm aware of. Okay, let's review the command line. LAStools. It's like LAStools, but it can handle many more points. Usually you can't, with LAStools, you usually don't do that merging of many tiles because it will run out of memory. LAStools usually doesn't run out of memory, up to 2 billion points. Otherwise it pretty much looks the same. I'm doing the elevation into this output directory, and I'm creating now a single, for all things, a single DSM that will have 1 meter resolution. And that's important, I'm using the tiles without overlap, without the buffers, because every point should appear just once in that merged file. Okay, running.
You won't be using, you won't be filtering the points. You won't be filtering the points since it's a PSM.
Oh, why didn't somebody say anything a little earlier? I forgot the filter. Now I'm using all points. That still gives you sort of a DSM, but it's a very, very rough DSM because in the forest especially, the tree's gonna look really crazy because it's gonna go up, down, up, down, up, down, up, down. So they look really cheap-jaggy. So yes, I forgot the filter and I have to do it again, which is really annoying. Because, you know, it takes a little while. Sorry for that. Let's try that again. All we have to do is add the filter. Next time a little early, okay? While we were reviewing the command. That's why we usually do that. First only, add, but thanks that you found it before the next step. Okay, so everything is the same, but we have first only also. Alright, so let's start it again. So we're now creating a raster in build format. That's just the same as a raster in .asc format or .tif format. What we're going to do next is we will create a hillshade. The user who looks at They want to know about the terrain characteristics and not about the acquisition characteristics. Okay. Mine is done already. So don't quit this tool because we're going to use the same tool again. And now I teach you one thing that's not documented anywhere, and I don't know where to document it. How can I delete things? I just press delete. So I click the first file here, and now I press on the keyboard delete, 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 delete. Now they're all gone. So it's surprisingly easy, but not so easy when you don't know that. And now I would like you to browse up one directory, and I think up one more directory. Oh no, I think into the 1 kilometer directory. Anyway, usually it only shows you LAS, and PHIL files. PHIL is an old format nobody really uses anymore. It was from Terra Solid from the early days, but now they also use LAS, and soon they're going to be using LAS also. But you can also look at these three formats. That's actually the Fusion, the Fusion format, DTM, the PHIL format, and the much slower ASCII format. So, in order to also look at those, to select them, you just click PHIL, and then there we go. And suddenly the PHIL shows up here as an option to select. And now I'm double clicking this, and here is basically the same area as before, the tiles, but now it's all merged and it's a raster. And I can treat that raster with LAStools as if it was a point cloud. However, it may be more efficient to use a raster program to create the hill shades now. In general, maybe using QGIS or ArcGIS or GDAL is a more efficient way to generate rasters, hillshade rasters from elevation rasters. But I just want to show you, you can also do it with LAStools by turning the PHIL into a point cloud on the fly. What do I mean with on the fly? Well, if you look, what does it say about the LAS file? It's not a LAS file, it's a PHIL file. It's not a LAS file. But it has to put something, it has to present it like it was a LAS file. So it says it's written, it's read using the LAS reader PHIL. And the LAS reader PHIL is sort of somebody who, your PHIL file, well, I'll make you look like your LAS file. I'll read point after point from you and present it as LiDAR points. Now, of course, I don't have GPS timestamps, so I use only the small point size, and otherwise, the bounding box is exactly the bounding box of the raster. So I have, it starts in the middle of each point, and here you just have a Z. There's no compression, there's no return information, because we are no longer have returns, we are in the raster world now. So okay. First what we need to do, we need to remove our filter, because if we do first only now, we're not going to get anything. There are no first returns. The concept of returns doesn't exist when you read a raster. So, and this time I want to create a hillside shading. Merge files into one, that's pointless. I mean, you can leave it, you cannot leave it, there's only one file. Now I want to create PNG. So now we'll turn the raster into a hillshade. One thing I always meant to mention, I forgot every time now. This one here. Verbose, every tool has that. What's the verbose? Verbose means while the tool is working, it will output more information about what it's doing to that black window. I mean, some tools already talk more than other tools because I haven't implemented it super consistently. But in general, verbose will tell you a bit more what it's doing. So especially if there's a problem, verbose can help you maybe figure out where the problem is. One more thing. Unfortunately, I haven't implemented projection reading from build files yet. Or I haven't implemented writing projection information to a .prg file that accompanies the build file. So I lost my projection information. Hence, if I do this now, I will not get a KML file because LAStools doesn't know where it is anymore. But I know where it is, so I can just quickly add it again. We are in UTM zone. Go. Is that right? 51? And southern, are we in the southern hemisphere? Northern hemisphere. Okay, so we entered the projection, and now let's run this again. Run. And review the command line. So now plus to them, minus V, that is a short for verbose. As input we have the bill. It only has elevation, but okay. We make it a hill shade. No first only or last only or keep class, there are no returns in the raster. We output into the same output directory. We call it now a PNG. And the UTM zone is 51 north. We need to add that again because we lost it in the build file. We don't need to. If you don't need the KML file, then LAStools, LAStools is using a triangulation algorithm to triangulate the grid because it turns the grid into points and then triangulates it. That is not very efficient. If I know it's a grid, making a hill shade is very trivial because you know where the neighbors are and you can do the difference calculations for the normals. So in a way, we're doing much more work. I just added it sort of for convenience. But in general, for a large-scale workflow, I would use a raster program to turn the raster into a hill shade, not necessarily LAStools. And there's a great package that can do that for entirely free. It's a little tool and it looks just like a LAStool. It's called GDAL. The GDAL command line tools. It goes like this. You can download them from OSGeo. GDAL is a super popular open source translation package. And a lot of the fancy tools you buy for a lot of money actually use GDAL in the back end. Because GDAL is allowed to be used for commercial applications based on the licensing. And actually a lot of these companies paid the GDAL developer to add certain things to it. That's how he financed himself. Okay, I think I'm done, and let's look at the output. So here's my new DSM. That's a single one. And how does that look now? One big one. You see, there's one big one, and there's a small one. And you already see the slight difference here. It's barely the same DSM, but it's slightly different. The difference is it's a shading. And if we go zoom in a little closer, let's look at our problem area. Now this is the raster. Look how uniform it looks. Everywhere it looks very uniform. And if I now compare the two, wow, like night and day. It's the same data, the same elevation data, but one is resampled onto a grid first and the other not. And guess, which one do you prefer? I think the new one is much nicer. The elevations are identical, but the visuals are nicer. If you look closely, you can still see it a little bit. Very little bit. So these structures are actually from the flight line, and it's very hard to get to resolve that completely, because there are different flights, and there are lots of instruments, and getting flight line. So some people, what they do before they create a hill shape, they actually cut away the overlap. You can also do that with LAStools. And that tool is called LAStOverage. LAStOverage cuts away the overlap. It puts like a line through here. And then on one side it uses the points from one line, and on the other side you use the other line. And this way you can remove these slight things here. And but you know, there's so much functionality in LAStools, like we go on and on and on. I mean, we're not going to make you LiDAR specialists in 3 days, but we're going to get you quite far. But there will be few things, so I have a reason to come back, right, and teach again. So I can't teach you all at once. So if anybody ever said, oh, LAStools generates bad hill shapes, well, LAStools has the possibility, unlike many other softwares, to generate hill shapes directly from the triangles, which allows you to see the flight line. But you shouldn't be doing this if you want to generate cartography quality hill shapes, because like every child knows, you should resample first. It's quite visible here. Also, it is especially drastic along the lines because it is well known that LiDAR scanners have the greatest error right along the lines, right along the edges. So in the center, they're usually more accurate than in the end, because these mirrors, as they rotate, they flip back and forth. That's when their direction turns. And people generally say these are the less precise points. So, and also, because the mirror is turning, the mirror needs to slow down. When the mirror is slowing down, the point spacing becomes smaller because it still shoots at the same rate, and the triangles get more and more small. So here they are almost, there's some zero-size triangles there that have very unstable normals. So if you use a point cloud, you will get these effects. But if you resample first, you can. Here was very good overlap. You know, I can't see it anymore. I can see exactly what the farmer did with his field. Also, I believe. Right? You really see. I can see he was planting onions, right? Surely. Okay. All right. You realize tomorrow you will do this workflow on your own. And I'll be not instructing you, I'll be going around and looking what you do and answer questions. Right now we're doing, then we do a bit more advanced stuff. Also, I would like you to install QGIS if possible. You all have QGIS on your stick. It's very self-explanatory. You just click on the .exe file and you just say next, 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 next. Yes, 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 yes. Until it's installed. Then tomorrow we can install LAStools from QGIS. And okay. Now on to something completely new. Let's go to Masbate. Where's Masbate?
Region 5.
Huh?
Region 5.
Region 5. Okay. Can I go to the airport, say one flight ticket to Region 5? No. Which island is it?
It's island of Masbate. It's
Oh,
an
Masbate
island.
is an island?
Yes.
See how ignorant I am. But hey, you have a lot of islands. You gotta admit that. I know a few, but not. So Masbate is an island. Great. So if we go in this folder, what's Masbate famous for? Huh? Cars? Really? Cows? Like leche condensada, like they make like cheese? Cheese? No.
That's the meat.
Oh, cows for the meat.
Yes.
Okay. Alright, like bulalo. Bulalo. Super bulalo. Bulalo. I think what I want to do what I want you to use is 2 kilometer underscore 2, the last one. And let's just have a look at those. Maybe I go back to last view. We have used it a while. Last view. Oh no, let's use blast to them to create a simple DTM for that. Because DSM. For DSM we don't need to really do much. It's sometimes nice to just look at the data to create a hill shading for it. Just to understand it. Certainly not a production quality thing. So I'm browsing with blast to them because it can handle more points. I'm browsing to Masbate, 2 kilometers, and I'm adding them all. So I have 4 slide lines here, 1, 2, 3, 4. I'm merging them all into one. So last to them. I loaded Masbate 2 kilometer underscore 2. I loaded all 4 flat lines. I say give me hill shade shading. I just want to have a quick look, and hill shade shadings are always good for quick looks. We didn't classify it, but remember the first return is already classified because that's not. That's nothing. That has nothing to do with classification. It has something to do with